So let's look at a new another function, right, where what I do is mostly this. So let's say for int I is equal to 1, I less than equal to n, I plus plus, okay, and my function is f int n, okay, something like this. And I do, then again in this function what I do is, again I say for int I j is equal to 1, j less than equal to n, j plus plus, right, and I just say print j, something like this, right,
Yep.
and I just close it, okay. So in this case I have two for loops, right. So for this
Yes.
for loop, basically I am executing these instructions n number of times,
N times.
n times, right, n number of times, and then again I do this n number of times, again another n number of times, right.
Yes.
That means this instruction gets executed n
N square times.
n square times, right, n, so n square times, right.
Yes.
So that means my time complexity is O n square, right. And now if we see on the graph, then what is going to happen is, and then again I'll just show it in this short graph. As we saw that when it is linear, it is like this, when it is logarithmic, it is like this, and when it is n square, then what is going to happen is, let's say this is 1, 2, 3, 4, and here 1, 2, 3, and 4, right. So when it is n square, when it is 2, it is like this, when it is 4, it is somewhere here 16, right. So if you see, so when your time complexity is O n square, you know, the number of times you execute the same set of instructions is, it basically it increases the square times, right, O n square time, and it is huge. So that's why when, so if you see the base time complexity is O1, okay.
Yes.
O1 means doesn't matter how much you do, how many, it just n is 1, so that means it is just constant 1, and the log it increases slightly, right, and then the next base is O of log n, okay. Then the next one is O of n, and then the next one is O n square. Yeah, O n log n we will see, certainly we will see that, right, O n square, right, and in between there is this O n log n that we will see, okay, O n log n, right. So that's what it is basically, right. So this is worst, not worst, but it is going the worst side, bottom, and this is best, right. So it can keep going like worst, you can even have n cube, right, and right. So whenever you design an algorithm or you tackle a problem, your effort should always be do it in less than O n square time, okay. There are some problems that you can't tackle, you know, less than that, but for most of the problems there are ways to tackle it in O n log n or lower time, okay. So if your solution requires O n square time, then you know that, you know, you have to think that is there a way to solve it in O n log n time or O n time, right. If yeah, if there is, then you should do that, otherwise O n square is normally it's not a good time, okay? But for some problems that's how it is. Some problems you can't do better than that, but give it a hard thought, okay. So that's there. Now let's see where O n log n will come into picture, right? So let's say, let me delete this picture, and then again new picture, right? So again, let's say your function is like this, f int n, right? And then again what I do is, previously it was n square, right? So so previously it was something like this: for I is equal to n, I less than equal to n, I plus plus, and then another for loop was for j is equal to n, j less than equal to n, j plus
G1,
plus, yeah,
J is equal to 1.
yeah, j, oh sorry, j is equal to 1, yeah, sorry, you are right, I is equal to 1, and and then what I used to do was print j here, right? So if I change this to for j is equal to n, j greater than 1, and j equal to j half, right? So then this internal part will become log n, right? And outside is n. So that's how it will become O of n log n. Okay, and many times this basically many binary tree or even what other I mean many binary tree algorithm, it can come into this time complexity, right? Yeah, right. So for example, if I have to build a binary tree, binary search tree from an input array for n numbers, then it will be n log n, because what I'll be doing is I have to put the outer loop, I have to take each number from the array, and then I have to find the proper place for that number in the binary search tree, right? So I have to execute the outer loop n times, and then when I place, I find a proper place for that number, it is basically O of log n. Okay.
Same with building heaps, right?
Heap, yeah, yes, exactly. Same when we build the heap. Okay. So that's how basically the time complexity works.
Yeah, right.
Okay. So any question on that?
No, I understood.
You understood, right? Okay, great.
Yeah.
Okay, so that is good. Now, so let's take one problem, and before I take the problem,